Hello, everyone. I welcome you all to my AI project that is based on cattle breed recognition and surveillance. Um, Being in East Africa, the most common economic activity carried out is cattle breeding and cattle rearing. So it is a key part of our economy as it supplies it adds to the varieties of meat on the market and also supplies milk. This project is based on the challenge that is faced by many cattle farmers, which is keeping count of the total number of cows they have. Some of the farmers, some of the cattle farmers here in East Africa hold so much cattle that they don't know how to take care, how to count it, and which makes keeping up and planning for these animals in terms of food and vaccination very hard. This brings me to a point where we can apply AI to solve this problem. This AI is meant to keep track of the cattle on the field at a particular time based on their breed. This shall ensure that the count of the animals is kept constant and the farm activity is also carried out efficiently. The dataset that I've chosen to use is from Cargo and has 5 different cattle breeds, which include Ayrshire cattle, the brown Swiss cattle, Holstein Friesian cattle, Jersey cattle, and the red Den cattle, which cater for the most popular cattle breeds that are kept by farmers here in East Africa. The link to the cattle breed dataset is given in the link below. The factors that I considered while choosing this dataset include the completeness of the dataset. This is because it caters for the most popular cattle breeds that are kept by the farmers. This dataset is consistent in such a way that the the data in this dataset can easily relate to each other. Then the constraint of the data is because it is constrained to only 5 breeds of cattle and it's not open-ended, which allows it to properly classify whatever image is fed into it into one of these five breeds of cattle. Then the uniformity of the data, all the pictures in the data set provided are 300 by 300 pixels, which makes it easy and more understanding to the model to classify. The features that are to be considered include the shape of the cattle. As we all know, these different breeds of cattle have various shapes and sizes. So the AI model is able to differentiate all these cattle breeds based on the size or the length of each cattle. Then the images in the dataset are also in RGB, which means the model can easily differentiate one cattle breed from the other based on their color. For example, the Frisian and the red Den cattle are completely different colors, and this is very good for classification. The categorization of the data, as previously said, the data has been split into 5 categories, which means it is very easy to classify the data that is fed into one of these 5 categories. There are a variety of images of each type, which means the data is given quite an adequate amount of data to work with in order to learn and understand the appearance of each cattle. The labeling of the data is done in such a way that in the training, each cow or each cattle breed is well labeled to train the model on what each cow looks like. This enables it to easily classify data that will be fed into it after the training taking place. Next, I'm going to take you through Bayesian theorem. The Bayesian theorem simply describes the probability of an event based on prior knowledge of conditions that may be related to that event. This is basically conditional probability, that what is the probability that one thing happened given the other thing already happened. So more of a cause and effect kind of approach. The Bayes theorem is stated mathematically in the following equation, which is seen here below. where A and B are events, and the probability of B cannot be 0. Then the probability of A given B is a conditional probability. That is, the probability that event A occurring given that event B is true. It is also called the posterior probability of A given B. Then the probability of B given A is also a conditional probability. That is, the probability of event B occurring given event A is already true. It can also be interpreted and as the likelihood of event A given a fixed B. Bayesian theorem is also very important in machine learning and is one of the technologies that actually helps make the right decisions at such times, and the Bayes theorem helps make those conditional probability decisions even better. It helps immensely in getting more accurate answers, especially when the model is fed with even more data. So more data implies greater accuracy on the side of the results that we expect from our model that is being trained. The more data you have, the more accurate the results can be determined. Thus, it makes the conditional probability a must to determine or predict more accurate chances of an event happening. Next, I'm going to take you through the naive Bayes. The naive Bayes is a simple algorithm that utilizes the Bayes rule together with strong assumption, underline the word strong assumption, that the attributes are conditionally independent given the class. So while this independence assumption is often violated in practice, the naive Bayes nonetheless often delivers competitive classification accuracy. As we looked at Bayes, the Bayes theorem actually doesn't state this assumption of conditional independence, rather of independence. It just states the theory as one event being dependent on the other. But naive Bayes goes ahead to emphasize this particular part of being independent. Coupled with this assumption, efficiency, and many other desirable features, this leads to naive Bayes being widely used in practice. The naive Bayes is used in real-time predictions, multi-class prediction, text classification, spam filtering, sentiment analysis, and recommendation systems. Next, I'm going to take you through Bayesian networks. A Bayonet is simply a data structure called a Bayesian network that is used to represent the dependence among variables. It is also used to represent essentially any full joint probability distribution. It's a directed graph in which each node is annotated with quantitative probability information. The Bayesian networks, each node corresponds to a random variable, which may be either discrete or continuous. Now, the directed links or arrows connect each pairs of nodes. If there is an arrow from node X to Y, X is said to be a parent of Y. The graph has no directed cycles, and hence is a directed acyclic graph. Now, each node, that is Xi, has associated probability information that quantifies the effects of the parents on the node using a finite number of parameters. Difference between Bayes' theorem and naive Bayes, as previously stated, naive Bayes assumes conditional independence, where Bayes' theorem doesn't. This means the relationship between all the input features are independent of the Bayes' theorem. Next, the difference between naive Bayes and Bayesian networks. The naive Bayes assumes conditional independence. However, the general Bayes nets will allow the user to specify which attributes are in fact conditionally independent. Then this great work has been collected from these sources, from Stack Exchange, the Bayesian networks and naive Bayes from artificial intelligence, a modern approach. And this is my link to the data, to my data set, which is called the Category dataset on carbo.com. Thank you so much. And hopefully this work is able to inspire future innovators to join me and we simplify the lives of farmers here in East Africa. Thank you so much. Peace.